Alright, here's a screencast for 1.2, analyzing graphs of functions and relations. So the graph of a function is a set of the ordered pairs, so that x is in the domain of f. So x corresponds to domain, and f is the range, because f is the y value. So the value of the function is the distance y of the graph from the point x on the x-axis shown below. So you can use the graph to estimate function values, and you've been doing this already. So for instance, at x equals 1, right, here's 1, we can look and it roughly looks like this would be a y value of 1 versus f of 3.5. Okay, so here's 3.5 is about here. So we can estimate, maybe like 2.5 or so. Right, depending on how much I zoom in, how much I estimate. So we can look and we can estimate that the y value, the function value, is 2.5 here. Okay, so we indicated it. Now we need to confirm algebraically. So f of 1, we have the function. So let's go ahead and plug in. F of 1 is 1 squared minus 4 times 1 plus 4. So this is 1 minus 4 plus 4. We were exactly right. The answer is 1. Now we plug in 3.5. 3.5 squared minus 4 times 3.5 plus 4. So go ahead and plug in your calculator. Alright, so after you plug in your calculator, you see the answer is 2.25. Okay, so it's not exactly what we estimated, but we were close, right? If you would have estimated that this was 12, that would totally be wrong. But 2.5, 2.25, that's a pretty good estimation for our eyes. Alright, let's use the graph to find the domain and range and write the answers in interval notation. So remember, domain is the x, range is the y. So according to, let me change the color. So we have domain is going to be blue and range will be green. So range is the y value. So it looks like the lowest value we have is -4 and the highest value is 0. So all of our y values are between -4 and 0. There's no y values above 0. There's no y values below 4. And notice that there's a hole, so I don't want to include y equals 0, but I do want to include y equals -4. And we always go smallest to biggest, left to right. So include -4 with the square bracket, exclude 0 with a parenthesis. Now I can look at the domain. I'm going from -4 to 4. Right? There's no y values left of -4. There's no y values to the right of 4. And so I want to go from -4 to 4. And we're having parentheses on both ends because they're open circles. We don't want to include it. Now on the second graph, this roughly looks like it's a, quadratic, it's a cubic function. And the ends are going off in opposite directions. So it doesn't say, but there's little arrows. It's implied that the function's going on forever. So it looks like it's a cube function. It doesn't have any holes, no places it's not defined. There's no endpoints. The arrows go forever in both directions. So the domain is actually going to be all real numbers. But in interval notation, we say -infinity to +infinity. And the range is the same. The arrows go in both directions. So if I would zoom out, so imagine that this graph, that's a small piece, right, a small little square on your paper. Imagine that I had a graph paper the size of California, right? Eventually, we could zoom out enough that this graph, it would cover all the x values that you could possibly think of. So that's why I said the domain is all real numbers, although I don't see the y value when x is 6. If I zoomed out enough, if I had a graph paper large enough, I would be able to see the y value associated. All right, part C, this looks like an absolute value function, so being able to identify the type of function helps you remember some of the characteristics and what's going on here, especially when you go into calculus next year. So the domain are the x values, and it seems like, once again, we have arrows at the end. It's implied that this graph, the function is going off in both directions forever. Now the issue is this hole right here. So it looks like the x is domain for all numbers except where we have a hole, which is at 2. So I want to go from -infinity to 2, cut out that 2. So it's a parenthesis union parenthesis. I'm cutting out just that one hole. So I have that whole interval to the left, and let's tape it, combine it with the right interval that goes 2 to infinity. Okay, so that's our x values. So x is left and right. It seems like I have all these numbers. This is the way I wrote it on the notes. All right, I'm drawing a little number line for myself. I want all numbers except 2. If I do that with y, it seems like I have all y values, and then wait, there's no y values less than 1. And there's a hole, right? I don't even have a y value that's equal to 1 because it's a hole at x equals 2. So I'm going to go from 1 to infinity. And notice parentheses are on both sides. So just remember, square bracket means we're including it. It's where you have a closed or filled circle, and a parentheses where you exclude the value, right? It's an open circle. We don't want to include that in our domain. All right, let's try again. So I like drawing these little number lines at the end of my graph because then it tells me, you know, it's easier to see like, okay, left to right, horizontally, that's my X, that's my domain. And then vertically, up and down, that's my Y value, that's my range. And so drawing these number lines, you know, horizontally and vertically helps me visualize the interval better. Now this one's a little tricky because there is a gap, there's a jump. Now you might be tempted to say, wait, there's a hole at x equals 0, so I have to exclude it. But notice down here, there's a filled circle. So this is just like a piecewise function that we covered in the last class, where I'm jumping at x equals 0 from one function to another. So in actuality, I'm going from -8 to 6. I have a y value at x equals 0, so I can include every number between -8 and 6. And there's filled circles at the end. Now, it's not a smooth transition, but I still have that x value. I can still plug in x equals 0 and find a y value. And then my range. Okay, so I see I have a hole up here. I go all the way down, and then I have a filled circle, so that's this left one. And then I have like a filled circle here. Okay, whatever. So I have this number line. I'm going from, you know, let's see, 8 down here to 0. So left to right, smallest to biggest, I'm going from 0. I include 0, and then up to 8. But I don't want to include 8, so I draw that parenthesis. All right, let's keep going. So remember, if you have questions as you go through the screencast, go ahead and pause it, write down the exact question in your notes, and look, and like where in the notes was your question. That way in our next class, you can actually ask me. And then I will know exactly where you were at when you had that question. All right, to find the y-intercept, find f of 0. AKA the y-intercept is where your x value is equal to 0. So plugging in x, that's really what it's all telling you to do. So if we plug in x, this is our y-intercept right there on our graph. The x-intercepts, so x-intercept is where y is equal to 0. Oops, different color. It's where y is equal to 0. And these are called the zeros of the functions, the roots, the solutions, the x-intercepts. Those all mean the same thing. So these are all of the x-intercepts. Okay, so we learned about these in Algebra 1 and Algebra 2. So to find the x-intercept, it's on the x-axis, it's where y is 0. To find the y-intercept, that's where x is 0, you're on the y-axis. To find the zeros of the function, set the function equal to 0 and solve for the independent variables. Use the graph of the function to approximate its y-intercept in zeros and find these values algebraically. All right, so let's go ahead and let's try this out. So the y-intercept looks like I'm crossing at 0, 0. I can, you know, plug in algebraically and prove it. So remember, we're just plugging in 0. So 0 cubed minus 0 is 0. Okay, we're good to go on that one. Now the zeros, these are another way to say x-intercept. And to find the x-intercept, this is where y is equal to 0. Okay, so it looks like we have 3 of them. It looks like at x equals 0, -1, and 1. So if you want to write it just like that, the way I wrote like x equals, or you could write the x comma y, the coordinates. So 0, 0, 1, 0, and -1, 0. Okay, so we need to plug in. So I have 0 equals x cubed minus x. So you might be tempted, right? I'm going to show you a wrong way, and I'm telling you it's wrong right now, so that way you don't do it. All right, this is the wrong way. So you might be tempted to say, oh, okay, x cubed minus x equals 0, add x to the other side, and then, you know, divide by x and square root. Like, no, you can't. The issue with writing this out, if you divide by x and x is 0, that would be undefined. We cannot do this. So I'm telling you right now, do not be tempted to do that. So the better way to do it is pull out the common factor. There's x in both x cubed and x. So if x squared minus 1, we can factor that further because this is a difference of squares. X squared minus 1 is the same as x minus 1, x plus 1. And then set each of your factors equal to 0. We find x is 0, 1, and -1 when you set each factor equal to 0. Okay, cool. So we confirmed our zeros. Okay. This is the last part of the notes for today because we split this into 2 different days. So g of x equals whatever, this function. First, let's find the y-intercepts. Remember, the y-intercept is where x is equal to 0. So x is equal to 0 right here. It looks like it's at -3. And the good way to find this, you just take g of 0. So plug in 0 everywhere. So 2 times 0 squared minus 5 times 0. All right, this is a little funny because we're plugging in 0 everywhere. Secretly, you just cross out any of the x terms and just look at the constant. Just look at the constant, that's your y-intercept. So we found it is 3 indeed. Check, check, that's the easy one. Now the zeros, a little more difficult. So the zeros are where y equals 0, right? These are your x-intercepts. So they're right here. So, okay, it looks like at x equals 3. All right, so that'd be 3, 0, and it's about halfway between 0 and -1. So that second 0 is at -1/2. So to write that, we would write -1/2 0. Okay, so when we try to find our zeros, our x-intercepts, we set the whole function equal to 0. Now this is a trick play because I gave you a function with an a that's greater than 1, right? That leading coefficient in front of x squared is greater than 1. So let's do it the case-if method. So multiply a times c, so that 2 times -3 is -6. Factor as normal. Let's see, so this is -6 and 1 plus 1. Adds -5, multiplies -6, yep. Okay, and then you must put the coefficient back in. See if there's anything you can simplify, because one of your factors might be able to, have a common factor, like that 2x minus 6. They're both divisible by 2. So we have x minus 3 and 2x plus 1. And if I set that equal to 0, set each factor equal to 0, we get x equals 3 and -1/2. So we were spot on here. That was solid. All right, and then that is it for the lesson for today. Bring your questions to the next class, and I will see you guys later.